Welcome back. Our lesson today is solving inequalities, and our learning goal is to solve and graph inequalities and to write and solve compound inequalities. And before we start, I want to do a take note so that you'll understand what the different inequalities mean. So we'll first start with this example. So this is x is greater than 4. Just going to write the word. So on the number line, here's 4, 3, 5. All the numbers greater will be shaded to the right. Then we have greater than or equal to. This one is similar, but anytime you have the equal to sign, we have a closed circle, which means included. Then we have less than. So now we're talking about all the numbers smaller than 4, which should now be to the left. And then we have less than or equal to. And kind of similar to the previous example, the equal to represents that the number is included. I want to write equal to. So we want to shade to the left, but this time a closed circle. So that's a review of the inequalities. So you'll know a little bit about which way it graphs, which way it shades, and then the open or closed circle. Okay, now we're going to learn how to write an inequality from a sentence. One thing that I wanted to go over is some keywords you may need. When you see the word at least, that means you need that number or more. That's greater than or equal to. At most, which means like no more than. That means it can't be larger than that. And you know, if it just says less or fewer, that would be less than. And greater. Or more. So that's that simple. So those are the most common. So in this example, they want us to write an inequality from a sentence. So it says 5 fewer than a number is at least 12. We just discussed at least means we need that number or more. And when it says 5 fewer than a number, so we don't know what the number is, so that's x fewer than. I know you would think you would put the less than, but we need an operation. So the only operation that can go there is the subtraction. And it's at least 12. So that's how you write it. Now here's an example I want you to try. What inequality represents the sentence, the quotient of a number and 3 is no more than 15. So you can pause the video and try it, and then we'll check our answer. Okay, if you did it correctly, quotient means division. So that's why I divided. And no more than goes back to it can't be more than, it's, at most, so it has to be less than or equal to 15. Now we're going to solve and graph an inequality. So we'll start with this example. And if you notice, we're going to have to distribute. Be careful with this negative, because if you don't do it correctly, you're going to get the wrong answer, and then you're going to graph it incorrectly. And then we're going to combine like terms. And then we'll subtract 16 from both sides. Now, when you get to a point where you have to divide, in this case, or multiply by a negative, this is very important that you remember this. I'll make it really big. When you divide or multiply by a negative, you have to remember that the inequality is going to flip. That's very important. So when we divide both sides by -6, now x is less than or equal to 2. And if you forget that, you'll graph it incorrectly. And then you'll draw on the number line. We have 2, 3, and 1. And because of the equal sign, we know that our 2 is included. And then it wants everything smaller than or equal to 2. So, of course, we will shade to the left. Now, I'm going to introduce something that is maybe new to some of you all, but that is called interval notation. Okay, with interval notation, this is another way of us writing the solution. Now, if you notice in this problem, it says that x has to be less than or equal to 2. And if you notice, our arrow is facing to everything to the left. That means all numbers to the left. And this arrow here, I'll draw another arrow here. This arrow here means that it is going on forever and it won't ever stop without any bound. So we call that negative infinity. Anything that is beyond on the right side, that is getting larger without any bound, is what we call positive infinity. So what is happening is we're saying that all the x values smaller than 2, which means that we are going from negative infinity. And when you write in interval notation, you always want to go smallest to largest. So when you write your interval notation, we're going to start with the smallest, which is negative infinity. And I'm going all the way up to 2. And because 2 is included, we use bracket. Bracket means the number is included. So that's the only time when you would use a bracket, is if the number is included in the solution. If not, then it'll be open parentheses. So for all of your solutions, we want you to write them in interval notation. So that's what that means. So in your book, it's not going to say that in the directions, but you want to make sure that you do that. Okay, now I want you to try this guided problem. I want you to solve this inequality, and then you're going to graph the solution and write your answer in interval notation. So you're going to pause the video so you can try it by yourself, and then you can check to make sure you got the right answer. Okay, if you did it correctly, this is what you should have gotten. Notice I have another example where you have to divide by negative. And I put my big arrow just to remind you to flip that inequality. And then after I graphed it, I wrote it in interval notation. So don't forget, this side is negative infinity, this side is positive infinity. So since there's an arrow pointing to negative infinity, we always go negative infinity, negative 8. In this case, you always go left to right, is what I was trying to say. So when you're doing interval notation, you always, just like we read, left to right, smallest to largest. And just a note to help you remember, you only use brackets when the number is included. If it's not included, you use open parentheses. And in the interval, the smallest to largest. Okay, this is a real world problem of using an inequality. And it says a movie rental company offers 2 subscription plans. One charges $36 a month and you can rent with no limit. The other plan charges $15 a month and $1.50 to rent each movie. How many movies must you rent for the first plan to cost less than the second plan? Well, first of all, we need to identify which one was the first plan. So it says $36 a month and you rent with no limit, meaning you can rent as many as possible. Okay, and then the second plan says $15 a month and $1.50 to rent each movie. So we have $15 a month, and that word "and" means plus $1.50 for each movie. So you can let it represent whatever you want. I'm going to put M for movie. And so since you want the first plan to be less than the second, then we're going to put less. And then you would just solve for M. So you would subtract 15 from both sides. And then you would divide. And I know a lot of students don't like the variable to be on the right side. So if you are going to switch it, be careful. Because right now, it's saying that you're going to have to rent more than 14. So make sure you write it like that. So when you write your answer, you can say you must rent more more than 14 movies. Okay. Now you try. Okay. A digital movie service offers two subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? I'm going to give you time to try it and then you can check your answer. Okay. So what I did was write the expression for the first plan, which is in pink, and the second plan I highlighted in black. And since they said how many songs must you download for the second plan to cost less than the first, that means the first is larger than the second plan. So that's why I use greater than. And I solved for D, and so that means that it's you must download more than 32 songs for the first plan to cost more than the second. Now we're going to do a special type of inequality. And here we're going to have to distribute again to get negative 6x minus 2 is greater than negative 6x plus 7. And here you would decide which way you want to add the 6x. But if you notice, either way, it's going to cancel. And you're going to get negative 2 is greater than 7. And we know that this is not true, so this is no solution. And no solution means that this is never true. Okay, so you try this one. And after you solve this inequality, I want you to say if this is always, sometimes, or never true. So here we get negative 12 is smaller than 8. And this, my friends, is true. And so this is always true. Okay, and for these you don't have to write in interval notation. Okay, now we're going to do and or types of inequality. Okay, so we got 7 is less than 2x plus 1, and 3x is less than or equal to 18. Now, an and inequality can be collapsed, and I'll show you what that means later. But right now, we have two different inequalities that we are solving. So you solve the left side, so I would subtract 1, divide by 2. So that means 3 is less than x. And you're going to divide by 3. X is less than or equal to 6. If you want to rewrite this, that means x is greater than 3. And x is less than or equal to 6. So if you had to graph it, Here's 6. Here's 3. Notice on the 6, it says or equal to. So close because it's included. And on the 3, it just says everything greater than 3. Now, because it says the word and, it means that it is greater than 3 and it is less than or equal to 6. This means that both inequalities are true, which means we would shade right between here. So in interval notation, we're basically saying that our solution is between 3 and 6, not including 3, but including 6. So it'll look like this. Not including 3, going all the way to 6, including. Okay. Now you can try 5 is less than or equal to 3x minus 1. And 2x is less than 12. So I'm going to give you time to try it, and then we'll check our solution. Okay? And after you solve it, this is what you should have gotten. X is greater than or equal to 2, and x is less than 6. And when you graph it, that means that since it's both, it has to be between. Then our last example, which will be, okay, now we're going to try an OR inequality. So on the left side, you're going to solve for k. You would subtract 7 from both sides and get k is greater than or equal to -1. And over here, I'm going to subtract 8 from both sides and get k is less than -5. So here's -5, here's -1. Everything larger than -1, including, would go to the right. Or everything smaller, not including, -5, would go to the left. Now, when you're writing interval notation, remember this is negative infinity, this is positive infinity. So, to write this, remember we do left to right. It'll be negative infinity to -5, not including. And then over here, we do -1. Now we're including it to positive infinity. And because or, whenever you're doing something or something, you want to unite these two intervals together. So we use this symbol, which means union. Okay? So that's how an or problem looks. We'll try this guided just to make sure you guys understand. Okay. Give you time to try it, and then we'll check our answer. Okay, in this particular problem, when you solve it, you're going to get W is greater than 8/7, or W is smaller than -3. Here's -3, 8/7, just approximate that. Okay, and then in both cases, neither of our solutions is included. So they both have an open circle. This is smaller. This one is larger. So you write your interval notation. You're going to write, remember, this is negative infinity, positive infinity. So it would be negative infinity to negative 3, union 8 over 7 to positive infinity. And that will conclude our lesson on solving inequalities. Thank you.